Okay, so this will serve as your Day 2 EOC tracker. Is also going to serve as your EOC question corrections for number 1, 16, 22, 25, and 31. We're going to be looking at how we create linear equations, predict values, and analyze residuals. If at any point I am going too fast, please feel free to pause it and turn on the closed captioning. All right, so again, we're looking at SID 6, 7, and 8. So we're going to look at question 1 first. So if we notice here, I have up our North Carolina Desmos test taking. Beginning with question 1, I'm simply going to press the plus button, table, and then I'm going to enter the data that we see. So 2.3, 4.2, 5.1, so on and so forth. Okay, so all of our data is in currently, and what I'm going to do is simply hide the expression list. I'm going to drag my screen, okay? So I'm going to imagine that there is a straight line here or a line of best fit, and I want to look for the point that is furthest away from my line of best fit. But how do I know that? Well, look at the criteria laid out by the statistician. So with this data, he said, based on the residuals plot, which this is, he decided to exclude one data point. He also decided that he was going to perform linear regression on the set of remaining data points, meaning he wanted to see the line of best fit. The result was that the new linear model fit the remaining data more closely than the original model fit the original data. Okay, so we want to know which data point did he exclude. So if we're sliding ourselves around sliding our mouse, around our Desmos, we notice that the only point that wouldn't fall on our imaginary diagonal line would be this point. So we're going to click on it, boom, that would be our answer, 8.2, 24.3. So we would simply highlight, circle, key in that answer. Okay. Okay, so here we are at question 16. It says the table below shows the U.S. average life expectancy at birth in years in various decades. Okay, so here's our information. It wants to know what's the meaning of the slope of the linear best fit equation for the data. So of course we can do this in our TI 83 or 84, but we can also always do this in Desmos as well. So what we're going to do is go ahead to our Desmos tab, and I do have it a little bit larger because it's easier to see. So I'm going to cover the data, but we should enter in X1 values of 10 to 8 going up by tens, and then we should enter in our years as the Y values. So here it is. I'll pause for just a moment to let you make sure you've done that. Okay. The next thing that we're going to do is notice that we have our plotted data here, but because we're talking about a line of best fit, we're really talking about linear regression. So we can accomplish that in Desmos by doing this. Sorry for adjusting the window a few times. I'm going to go down to our number 2 tab here. I'm going to click the plus button, and I'm going to enter f of x expression. Okay. Here I'm going to type in y subset 1, okay, regressed against, and in order to get the regressed against button, I'm going to click functions, stats, and click this, okay. That was functions, stats, and I'm going to click this little symbol here next to quantile, okay. You can also get that on your keyboard if you'd like. Then I'm going to type in mx, and again on x I'm going to do a subset of 1. Okay, and I know that my equation is always mx plus b, so of course I have to include b. Okay, so now what I've got going on is in green, I've got my line of best fit, okay? In blue, we have our original data points, okay? If I needed residuals, I could simply plot those by clicking plot, And it would tell me how far away from the line of best fit each one of my coordinates is, but we don't need that. Just wanted to show it to you. Okay. So according to this, our slope is going to be 0.207857, and our initial value is 62.6964. Okay. So it says what's the meaning of the slope of the linear best fit equation for the data. So really I'm looking for the M value. So the M value, remember, was 0.207. And so I'm going to be looking for 1 decimal place. And the reason why I know I'm looking for 1 decimal place is because I have only 1 decimal place, a tenths unit here. So in this case, it would be D. So we would have marked D. Okay, so looking at question number 22, it says the table below shows the number of hours 7 students studied for a math test and the grade each student earned on the test. So we have our X values, which are hours. Of course, we're going to click the plus, we're going to click table, and then, of course, it will pop up. So here are our hours of study. We have our test grade, or the Y value. I've entered those into Y1. Okay, again, in order to find our line of best fit, because it says how does Amanda's test score compare to the score predicted using the linear best fit model of data for a student who studied 3.5 hours. Okay, so I'm going to use Y1 regressed against MX1 plus B. Remember, to get the regressed against symbol, we're simply going to hit functions, stats, and this symbol here next to quantile. Okay, now that's going to give us our coefficient, or excuse me, our correlation coefficient here. It's going to plot residuals for us if we choose to, but the part that we're really interested in is our M and B value, because M is going to be our slope and B is our initial value. Okay, so according to this, the equation of a line of best fit would be 5.18717 times X plus 76.5187. Okay, so it gave us a specific X value when it gave us 3.5. So we're simply going to ask Desmos to solve it for us. So we're going to type in an equation, 5.18717 times the X value that they gave us, 3.50. Okay. Make sure you use your parentheses, plus the B value they gave us of 76.5187. Okay, so plus 76.5187. Okay, and notice in our little gray box here, it's going to tell us that that value is 94.673795. So because all of these are whole numbers, I know that I'm going to need to round my Y value to a whole number. Remember, anything that's 0.5 or above, we're going to round up to the next whole number. So in this case, the next whole number would be 95. So because the next whole number is going to be 95, we would say that she has 2 points lower because we simply take 95 and subtract 93 from it. So our answer choice would have been C. Okay, so the next question we're going to tackle is number 25. Marcus measured the height in inches Y of plants over the course of 3 weeks. The correlation coefficient between the number of days X and the height of the plants is 0.85, which could be concluded based on the correlation coefficient of the data. So for this, it's simply a matter of memorizing, and the things that we need to know for success are that correlation coefficients are between -1 and +1, okay, with 0 showing no correlation whatsoever. So no correlation, okay. So -1 is going to be a strong negative correlation. And +1 is going to be a strong positive correlation. Okay. So notice that anything that you get that's in between 0 and 1, the closer it gets to +1, the stronger the correlation is, okay? And the more strongly positive it is, I guess is the best way to put it. Between 0 and -1, the closer you get to -1, it becomes a more strong negative correlation. So if you had something like negative 0.3, that would be a weak negative correlation. Whereas if you had something like positive 0.3, that'd be a weak positive correlation, okay? So looking at 0.85, that's gonna be a strong positive correlation. So looking at the answer choices there, there's a strong, okay, so we're looking for strong in our answer choices. So A has strong, B has strong, C has weak, and D has weak. So I would have marked out C and D, okay? Then let's talk about this. There's a strong relationship showing that as the number of days increases, so as X increases, okay, the height of the plants increases. Well, is that true? Well, yeah, typically that's how plants grow. The longer they're in the ground, the higher they grow. So that's a possibility. So I would star that personally. Looking at B, there's a strong relationship showing that as the number of days increases, the height of the plants decrease. Well, no, typically the longer it's in the ground, it does not decrease. So the only answer choice that would have made sense was A. Okay, so here is our question number 31. The table below displays the walking heart rate and running heart rate of 8 girls in beats per minute. So our walking heart rate here, our running heart rate here, it wants us to use the linear best fit model for the data. We want to figure out what's the predicted running heart rate of a girl whose walking heart rate is 100 beats per minute. So if walking heart rate is X, what would Y be, okay? So we want to figure out if the X value is 100, what's Y? So we're gonna go back to Desmos, and I'm gonna pause it just briefly while I go back to Desmos and enter my data, okay? Okay, so I'm in Desmos, I've clicked the plus button, I've clicked the table. Okay, so we have our information entered in here. So our our walking heart rate is our X value, our running heart rate is our Y value. And remember, it's talking about the line of best fit for this question. And I'm going to make this a little bit smaller so you guys can see it. So we want to know what it would be at 100 miles per hour, or excuse me, 100 beats per minute. So because of that, we're going to use our line of best fit equation, okay? So for that, remember we're gonna type in y of 1 regressed against, and remember we're gonna use our little keyboard there. So keyboard functions, stats, little squiggly line, m of x1, okay, because remember we're talking about x list 1 and y list 1. So y list 1 regressed against the slope times the values of x list 1 plus b. Okay. And if we do that, we find out that our slope is going to be 1.20, and our beginning heart rate is going to be 44.77. So we're going to use that data to calculate an x value of 100. What would y be? So let's go ahead and figure that out. If I have slope m 1.20, just for accuracy, I'm going to type it all in, but you could have absolutely rounded that to just 2 places. That's okay. So 1.20352 times the rate it gave me of 100. Make sure you use your parentheses to close that back up, plus 44.7739, okay? And looking at the value here that's been calculated, that's 165.1259. So I want to go ahead and look here. All of these are whole numbers, so I'm going to round what we have, and I know that 0.1 would round down to a whole number of 165. So we could expect, based on the linear model of best fit, oops, that's not it. I definitely started writing the wrong one, so here we go. That based on the linear model of best fit, a girl who has a walking heart rate of 100 beats per minute would have a running heart rate of 165 beats per minute. Okay, so that will do it for SID 6, 7, and 8, active questions 1, 16, 22, 25, and 31 from the mock EOC. Replay this if you need a little bit more help. Raise your hand to ask questions, and we wish you the best of luck on SID 6, 7, and 8 on the EOC.